everyone, welcome to Python for Academics. In this exercise, we're going to count how many times a bibliography item has been cited in a LaTeX source file that could, for example, be your manuscript or your dissertation. Now, we're going to assume that citations are made through either the /cite or /citep command. Here I have an example LaTeX source file where I made a couple of such citations. Now notice when we use the /citep command, there can be multiple comma-separated tags inside that curly bracket. And we also assume that there might be some white space left in between those comma-separated tags. And we're going to start by first listing all of the tags that are available in the bibliography database file. In my case, I have this unique bibliography.bib file that contains a couple of bibliographic items. And inside of this LaTeX source file, I only cite 5 of those. So I do expect that some of those items will have a count of 0 citations. And we'll start again by importing the regular expressions library and the code to first create the list of bibliography tags is going to be the same as what we did in the previous exercise. So I'm just going to copy all of that code and paste it here. And I'm just going to change the file name of this bibliography database, and I will run all of those cells. So this will generate the list of unique tags that are present inside of this .bib file. Now we need to import and read the contents of the LaTeX source file, and we'll do that in a similar way to how we import the .bib file. So I'm going to write LaTeX source file, and we're going to open it in a similar way with a given directory, and the name is LaTeX source.text. We're going to open it for reading, and we're going to read the content of that file. And now we need to craft a regular expression pattern that looks for occurrences of this /cite or /citep command in the LaTeX source file. And I will first explain how we can generate this pattern. So here's the regular expression pattern, and I will walk you through step by step what all of that means. So in this bracket is the main capture group, where we are going to capture the interior portion of whatever is inside of this curly bracket after the cite or citep command. So here we are capturing any character. This is what the star is doing. That's capture any character but the right curly bracket. So this hat denotes a negation, so we do not want to capture the right curly bracket because that denotes that the cite or citep command has ended. So we are only interested in capturing anything that's inside of the curly brackets. So of course we capture anything that's between the left curly bracket and the right curly bracket, but only if all of that is preceded by the /cite or /citep command. So this P present in the square bracket and the star over here denotes that the letter P can occur 0 or multiple times after the cite command. And with this regular expression, we are going to capture everything that's inside of the curly bracket after the /cite or /citep command. Now notice that in the case of citep, where we have multiple tags inside the curly bracket, we're also going to capture all of the commas and all of the potential white spaces. So in our Python code, we're going to have to handle that and extract the individual tags. So I will first compile this regular expression pattern using the compile function from the regular expression library. And this will be my citation pattern. And I will just write that pattern that we've seen on the slide. So we capture anything that is not the right curly bracket, and only if it's preceded by the right curly bracket and preceded by the left curly bracket. And then we have the cite, potentially cite p command. And we're going to compile all of that as a raw string. And now there's this function inside of the regular expressions library, which is called find all, which can help us find all of the occurrences of that pattern in this LaTeX source file that we just uploaded. So we're going to use the citation pattern, and we're going to look for that pattern in the LaTeX source file. And if I execute this returns a list of all of the occurrences of that pattern in the LaTeX source file. So you can see that each element of that list is the interior of the curly brackets. And it looks like it did a good job. So the first citation is this one, which is indeed the first one that occurs. And then we have these three tags as the last citation, which is this last element in the list. So far it looks like this is going to be a useful command for us. And now we're going to loop over all of the elements in that list and extract the individual tags. So we're going to capture all of those individual tags into the citations list, which I initially initialized to an empty list. And we're going to loop over every match, so every element in that list. And now we have to extract the single tags from each of these elements. So we can do that by splitting every element in that list with the comma symbol. So the comma symbol separates the individual tags, and we can split them that way. And now every tag can also contain a white space that's just before it or maybe just after it. And the way to remove the white space is by calling this strip function on the tag that it has found. And this is going to be our citation. So now we can print that citation. And of course we can append that citation to this citations list. So now if we execute this cell, we see that we get the list of individual tags that have been found by this regular expression pattern. And again, it looks like it did a good job. So we get first these two citations, which are these two guys. And then we end with these three citations, which are present in this last cite b command. So the last thing that remains is to count how many times each unique tag from that unique tags list have been cited in the LaTeX source file. And we can create a dictionary that is going to have keys as the individual tags and the values being the counts, how many times this particular tag has been cited in the LaTeX source file. So I first initialize this dictionary to an empty dictionary, and now we can loop for every tag in this unique tags list, for tag and tags list. And we can create a key in that citations dictionary that has the name of the tag. And now we can count how many times that particular tag occurred in this citations list. Okay, so if we execute the cell, and now we can look inside of that citations dictionary, we see the keys of that dictionary are the individual tags, and the values are how many times that item has been cited. So it looks like these 3 papers have been cited 3 times in the LaTeX source file, and indeed it seems to be the case. So this citation, for example, occurs 3 times, and this one as well. And also notice that this textbook has been cited 0 times, which seems to be the case. So the last thing that you can do is you can, of course, copy all of that code into a standalone Python script, which is something that I did over here. And this particular Python script, I've written it for my dissertation because I was very curious what is the most cited paper in my dissertation, and we can check that together. So in this location over here, I've got my Python script, which is this code that we created today. And I've also got my LaTeX source file, which is my dissertation. And I've got this bibliography database file. So we can simply now run this how many times have been cited script. And you can see that I get a lot of tags in my database file. Some of those papers I never cite in my dissertation. There's many papers that I cited just once, and there's some papers which I cited multiple times. And it looks like we have these 2 winners that have been cited 20 times. And those 2 papers are actually really important papers for my dissertation, so I'm not surprised that they're the most cited papers.